In this video, we are working on probability problems. So the ones on the last exam, you could pretty much do a tree diagram for help. These are a little different. This would be hard to do a tree diagram for because first of all, we have unequal probabilities. And here we're talking about 4 questions, okay, with 3 possibilities for each question. So that would make a pretty overwhelming tree diagram. All right, so we really have to be able to use our rules on these problems. So first of all, most multiple choice questions have A, B, C, D choices. So just to change things up a little, we did several of these on the packet, right, where we had multiple choice questions and they had A, B, C choices. So the probability of correct was 1/4. Okay. Well, just to change things up a little, I made only 3 choices on this multiple choice test. So you're picking from A, B, or C. Okay, so your chance of getting a correct would be 1/3, whereas the probability of getting one incorrect would be 2/3. Okay, so if you want to find the probability that all 4 are correct, so we've got to do correct, 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 correct. So this is correct and correct and correct and correct. When you hear the word and, that should tell you multiply. So for each correct, the probability is 1/3. Okay, meaning that I'm going to multiply 1/3 times 1/3 times 1/3 times 1/3. Answers in exponential form make very good answers. Right? I'm totally content with an answer like this. Let's see, 3 to the 4th power. So if I square 3, that would be 9. And then 2 more 3's being multiplied would make it 81. Okay, so certainly 1 out of 81. When we talk about, 1 out of 81 would be a perfectly fine answer too. But when we talk about considering whether or not your answers are reasonable, if you're guessing, your chances of getting things correct should be very low. Okay? So then all incorrect, that would be 2/3 times 2/3 times 2/3 times 2/3. Okay, so 2/3 to the 4th. So 2 to the 4th is 16. Okay, so 16 chances out of 81. Okay, so then the next question says exactly 1 correct. Okay, so if I started computing probability of correct, incorrect, so that would have to make 3 incorrect if 1 is correct. Okay, so then I would have to multiply 1/3 for the correct, and then 2/3 for each of the incorrect. However, this is not the only way that this event could occur. Okay, I could say or, which we know means add. I could put the correct here, right, second, or I could have it third, or I could have it 4th. So I'm just going to put third just for this, making me write faster, or it could have occurred 4th. Okay, so if you were to figure all these probabilities out where you do right here 2/3 times 1/3 times 2/3 times 2/3, you're going to see you're going to get these same fractions. They'll just be in different orders. All right, so the easiest way to handle this then is to say, well, then there were 4 ways it could happen. Therefore, I'll get this same answer 4 times and have to add it 4 times. Well, adding it 4 times is the same as multiplying it by 4. Okay, so this is a perfectly good answer for the exactly 1 correct. Okay, you can leave it like that. Now, at least 1 correct. So this is our key to do 1 minus, because remember, 1 correct could mean I get all correct, which is unlikely. I get exactly one correct, which is right here. I could find the probability of getting two correct, right? The probability of getting two correct. Oh, actually, that'd be more complicated. Yeah, so I could do two correct, then I could do three correct and add those all up, okay? But again, that is so much more work than doing complementary events where I say, what is the opposite of getting at least one correct? So if you say, oh, I hope I get at least one right, and then the teacher says, nope, sorry, you didn't get at least one right, you got, and then what you would have gotten if you didn't get at least one right is all wrong. Okay, so we would do 1 minus getting them all wrong or all incorrect. Okay, so again, I am completely happy with answers like this. Let's see, if I subtracted these, I'd get 65, right? Is that right? 65 plus 16 is 81. I think so, because 65 plus 15 is 80, and then the 1. Yep. So again, either this form or this form would be fine. Okay, so let's take a look at the next one below. Maybe try this yourself and then watch me. Okay, so if the probability of getting rain, so we've got the dry season, okay, so they only have a 10% chance of rain on any given day, which means that the probability that it's dry is 0.9. Okay, so these are opposite events, so they have to add up to one whole. So probability that it is dry every day for the next 3 days. So I want dry, 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 right? So 0.9 times 0.9 times 0.9. Okay, so 0.9 cubed. Probability it rains 1 day of the next 3 days. Okay, so I want 1 day. I actually should say probably it rains exactly. I don't know if that's clear enough. Probability that it rains exactly 1 day of the next 3 days, just in case that's not perfectly clear. But it's exactly and not at least one. Okay, so I want rain, dry, dry. Okay, so probability of rain is 0.1. Probability that it's dry is 0.9. So I'm going to actually write, instead of writing 0.9 times 0.9, I'm going to write 0.9 squared. Okay? But again, there are different ways this could happen, right? The rain didn't have to be on the first day. It could have been dry, rain, dry, or it could have been dry, dry, rain. Okay. And again, if you figured out each of these separately and added them all together, you would notice that you'd keep on getting the same combination of these numbers, just in different orders. Okay, so the easiest way to write your answer is there's 3, and being multiplied by this, there's 3 ways that it can happen. And this is the probability of 1 rain with 2 dries, but it could happen 3 different ways. So we multiply it by 3. So it rains at least 1 day during the next 3 days. Okay, so again, what does it mean if it doesn't rain at least 1 day? Right, that would have meant that the opposite of that, if it doesn't rain at least 1 day, then it was all dry. And we didn't find the probability. Oh, yes, we did. We did find the probability that it is dry for the next 3 days. Okay. So I could simply do this. Okay, so again, to reiterate, whenever you see the word at least one, think one minus the opposite. Okay, the opposite of at least one is all of something. All right, so again, thanks for watching.